So thank you for the introduction. Let's start. The title is When Hackers Do Good, the Future of Security Testing. So my name is Rito Ishii. I'm head of product development of Airlock Gateway, which is basically a web application firewall and an API gateway. And maybe beside moving here things around on a Scrum board, I'm heavily involved around information security, especially web security. I'm more on the defense side, you will see then. But of course, you also have to know what the hackers do, otherwise you cannot have a good defense. So what's today's agenda? We first talk about a little bit web application firewall. They're more specific regarding how you improve such a product. Then I will show you a bug bounty program. You can also participate in this bug bounty program when you want. I think it's quite unique. It's really a cool program. And I will show you some hacker reports, what they do, what the hacker do on our platform. And I will wrap up with a short conclusion. So let's start. What's a web application firewall? So basically, assume you have a service, an HTTP service, like a website or an API, web API. It's usually accessible over the internet, and it's accessible maybe with a browser or with a mobile device, something like that. Key protocol here is HTTP, and we assume you have vulnerabilities in this service. That's a valid assumption. It's almost impossible today to create a complex system without vulnerabilities. And the goal of Airlock WAF, that's a component you deploy in front of the system. It's usually a network component like a reverse proxy. And this proxy has to solve the decision problem, what's good and what's bad. So whether we have traffic from an attacker here trying to exploit this vulnerability, or whether the traffic is good. And that's really a really hard decision problem you will see later. So how can we improve such a product regarding security? So one possibility is doing pen testing. So we ask, for example, a security company. There are a lot of pen testing companies out there. Please test our product. We can give them our product. They may deploy a service in the back end, and they test how well it performs, how good the security is. Another approach is doing fuzzing. So fuzzing is basically you send special constructed string to the system, and you check whether it's bypassed or you evaded the WAF and maybe the code is executed on the back end. The cool thing here is you can automate that. You can make much more requests than a human, of course. It's not the perfect testing method, I think, for a WAF. But we will see that later. One other approach, maybe when humans are involved, you think, okay, then we do it with machine learning, then we can scale up, everything is better. That's also not the solution to improve a WAF, because usually you do not have enough data, or you do not have the label data to really create models there that are as good as our current system we have. And so most of the work is still manual analysis, maybe with tools like fuzzers. We do that in-house. And we thought, can we somehow improve? So we do basically all of these processes, but most of the work is here, and that's a lot of manual work. And we thought, can we somehow automate this process? And maybe to give you a short, or to give you a feeling what that means, manual testing, we have a lot of web application built with vulnerabilities in it. Here is one of these. And we test with these applications whether code is executed. For example, here we have JavaScript code, which is injected in this link here. And when you hover over the link, the code is executed. And now you can here test whether, for example, such a protocol handler is executed when you click on the link. Yeah, it is. Okay, that should be blocked by the WAF. What happens when I make a space in between? Okay, then it's not blocked because JavaScript here is no longer a keyword. There's a space between. What happens when I put a new line in between? Okay, it's still executed. So there are a lot of really strange things happening in these parsers, and the WAF has to consider all these variants to be effective, such that we really can detect all the attack payload and the hacker is not able to bypass. We also have to deal with all possible encoding schemes, like here, for example, Unicode encoding, that's also executed. That marks an A here. That's on the offense side, I would say, or testing side. And the defense side is even worse. So where's Michelle here? So that's really, really complex rules we are dealing with. And it's quite hard to extend them. These rules are based on regular expressions. So that's technology you maybe say from the 80s or 90s, but regular expression involved a lot. So there are a lot of possibility, and it's still the best tool for us. We tried it with machine learning and other approaches, but it's still the best tool because of this backtracking technology or concept, which fits best for what we are doing here. So that's basically what we do at Airgon and Airlock, to improve the WAF. And now we thought, can we somehow improve this thing with a bug bounty program? And for this, I would start with what is a bug bounty program. So usually you have a company that's here our building in Zurich, and this company gets tested by a hacker. So a hacker tests, for example, a productive system like the website of this company or what else. Then he reports a vulnerability and gets back a bounty, usually in form of money. Can also be any other reward. And there are a lot of platforms where you can run such a bug bounty program. The platform deals with all these payout processes, with registrations and so on. So when you want to become a hacker, a white hat hacker, you can register on one of these platforms, take a look what programs are there, and then you can start hacking, and maybe you get rewards. So maybe some numbers regarding bug bounty platform. So these numbers are from HackerOne. That's the platform we are using. That's quite a large platform. So there were 9 hackers in 2021 who earned over 1 million with bug bounty programs. The biggest payout in 2020 was around 100K. Most of the hackers there are self-taught, but they usually, or many of them studied computer science, but the knowledge you need, usually you do not learn it in computer science, but you have a really good basis to extend your knowledge and learn all these different technologies you need. They come from all over the world, basically, and a really interesting aspect, especially for our program, is they are not only motivated because of the money. That's on the second place. So most of them, they participate in bug bounty programs because they learn things. So they learn technology. It's also why I studied here information security, because when you want to know or how a system, or when you want to hack a system, you really have to know how it works, and that's really cool. So I think there are other hackers. That's the reason why they participate for such a program. And having fun is also over 60% doing for fun. So most of the hackers, they do it part-time or under 25 years old. And the technology they attack, that's exactly the field where we are in. So they attack websites, APIs, and after that comes mobile devices, IoT, and so on. So now, how does our bug bounty program looks like, and how is it different from all these classical bug bounty program? So in a classical bug bounty program, You have a productive system, for example, here the ETH Zurich website, and maybe there are vulnerabilities in it. We don't know. Maybe it's perfect. Maybe even ETH doesn't have a perfect software here. And we have the crowd, all these white hat hackers all over the world, and they try now to exploit one of these vulnerability. And the question here, is it really possible? Is there a vulnerability? Is this vulnerability reachable? Is the configuration in the system in a way that you cannot exploit it? Maybe there are security measurements in the system who blocks the attack. So it's not clear whether you really can attack, whether there is really a vulnerability or not. So it's not clear whether it's worth attacking this for money. On the other side, our bounty program is different. So we also have a web service, but it's not a productive one. It's one where we implement a lot of bugs. So we implement here dozens of bugs, and these bugs are trivial to exploit. So we even provide the attack strings, the exploit code to the white hat hackers, so that they have all the information. We even provide them sometimes the code here to better understand how this vulnerability works. And our goal is to put the web application firewall in front of it, and this WAF should block all the attacks, and the hacker should bypass this product to reach these vulnerabilities. And the important thing here is this web application firewall is configured in a standard mode. It's not in a paranoia mode. There are a lot of features on the WAF. You could enable that the exploitation is almost impossible, but a lot of these features, they need a lot of integration effort. And customers usually don't have this time, or certain customers do not have time to spend so many hours to integrate the product, so they use the standard mechanisms, the standard tools, and we want to also prove these standard mechanisms. So it's really deployed in a way, when you make online banking, for example, in Switzerland, then you probably are surfing or filtering, you get filtered by an Airlock, and that's the same configuration. So that's really a system that's out there. And for us, it makes totally no sense to test some paranoia modus, because the platform is quite expensive, and we really want to spend money with that because we want to improve the product. And the cool thing here is that matches to the motivation of the hackers. It's like a capture the flag style program, but you get money for it. So it has gamification character. The vulnerabilities are built up with challenges. You will see that later. And the hacker can really learn a lot of things and get money at the end when they can bypass our product. And I would like to show you how this program looks like. Where is it? Here is the main page. On the right side, you have these vulnerabilities. Even you see the bounty amount you get when you can bypass this challenge. So there are some challenges up to $2,000. There are certain challenges which are easier. Here on the like this SQL injection, for example, where you get between 100 and 250. And here, as I said, you have a sample exploit, so you could enter this sample exploit. It gets blocked by the WAF, but when you somehow can manipulate this exploit or this exploit code, then you get the money. And you can also say on which databases you want to execute these SQL statements. So it's really an artificial environment. You never have this situation when you attack a productive system, because then there you do not have a field where you can enter your exploit code, and maybe you have to bypass a lot of products and things. And here you really have direct access to the vulnerability. It's only the web application firewall is in front of it. And as an example, when I here put, for example, the random strings, you see it it doesn't get blocked, so we don't have any paranoia mode where it checks for keywords or something like that, because you cannot use that in production because you would have too much false positive. So these are really rules you can use in practice. And here, this is the description, what you have to do to get the money. Basically, you have to extract certain information from the database. And also a cool thing is you can send us multiple reports and you get rewarded for each and every unique idea. So as long as we think that's a new idea, that's something different than we have seen before, then you get the money. That's also quite unique because usually you get only the money for finding a vulnerability, for example, in Gmail or so. But you cannot get the money for 3 different ways how you bypass the service. That's the program. Let's continue with the presentation. So let's take a look at some reports. These reports here, they have really high quality. So the hackers report the attack string here. That's the attack. They describe how it works. They say where they tested it. For example, here the JavaScript code gets executed at least in these 2 environments, Firefox and Chrome. And here, for example, this attack string executes the alert function, and for us it's enough to execute the alert function. And we also do not have any special alert rule. The only goal is to execute JavaScript code. You could also execute any other function in JavaScript. You do not have to deploy a reverse shell or something complex. That would be much easier for us to detect, but we would really it's enough to make this least effort, I would say, to execute such a function in the browser. And here, this function is a string basically. And just by the way, it's impossible to filter the name here, alert, because it's a string, and a WAF cannot evaluate the string because you can concatenate letters, you can encode it in thousands way. That's not possible. Otherwise, you need a JavaScript runtime, and you cannot do that within milliseconds during a request. So we have to somehow filter the thing here before, and that's quite crazy what the hackers report here. JavaScript syntax we never seen before, and they get rewarded. That was a $200 finding. Here is another one. That's the attacker payload again, and now here we take a deeper look what this payload does. For this we have to talk about the vulnerability. It's again a JavaScript vulnerability. Assume you can inject into these quotes here, you can replace this injection string here with this attack payload. And what it does, it basically redirects the browser to a different site. That's this location here assignment. And so you can steal information from the site, like cookies, or when you are in online banking, maybe your balance or things like that. So that's really dangerous when you can inject things like that. And the hacker used here different encoding schemes. We can handle that on the WAF, like this Unicode you also seen before. And we can also, of course, decode this here. That's URL encoding. And but the problem, or what he found out here, is that this present FF, that's 1 byte, and it represents the highest value of a byte. Everything is a 1. And in the web, you usually use UTF-8 encoding. So UTF-8 is the character encoding, how you represent a character in binary, for example. And the problem is that this is an invalid sequence of bytes in UTF-8. So after this byte, a different byte must appear. So that's basically invalid in UTF-8. Now the problem was that browser ignores this present FF and decodes the rest as UTF-8. And we did it differently. So we said, okay, that's not UTF-8. We fall back to a different character set, like Latin 1 or something like that. And we saw here these 3 letters. These are these 3 bytes here, E2, 80, and A8. And the browser saw something different. He decoded these 3 bytes as a single character, which is basically a line separator. And when you take a look at this JavaScript snippet and this snippet, here we have a comment, and this single line comment is terminated with this symbol, so this code here gets executed. And on this side, we don't have this termination character, so this code would not be executed. So that was the way to bypass the WAF, and that's a quite common attack scheme. So you try to send something that gets differently interpreted by the WAF than the application, like this picture here, where you have the old woman and the young woman, and maybe the WAF sees the old woman and the application sees the young woman. So that's these 2 possibilities. And when you interpret a string differently than the application, then things can go wrong, and the application or the web application firewall may be bypassed. So that was a really cool finding. We got 2 of these findings. One was a $200 bounty, one was an $800 bounty. Here are some other reports. I quickly go through them. So these here is SQL syntax. SQL is really huge. That's unbelievably complex to prevent SQL injection. The hackers even decode they do not only read the documentation of these databases, they take a look at the code of the databases and search for things that are not documented, where they can bypass the WAF with this information. So that was a $150 finding. Here, one other injection attack, this red one, where most of the WAFs do not see the operator, the binary operator OR, because there is no word boundary between OR and this \n. So a WAF who would check for substrings OR, that's completely, again, useless, because there are so many English and German words with OR as a substring. You cannot block that, so you have to be much smarter. Therefore, we have these complex rules. Yeah, that was a $200 finding. So where does the hackers for our program come from? So most of them are from North USA. We have a lot of hackers from India, Asia, Russia. And it's quite crazy how much traffic we have, or really manual hackers we have on this platform. So that was last year, we had over 6,000 unique source IP addresses attacking the service. We got over 350 reports, and 240 reports were rewarded. So they got a bounty in these 2 years. The program is now running, and hackers earned up to $10,000 a single hacker, and certain findings were around $2,000. So that's one of the feedback I got from the hacker, which is really nice. So this has been an awesome testing platform, and have been so fun to try different things, techniques that aren't often used in the real world. Yeah, I think that's quite a unique program. And this makes your WAF an extremely strong protection. We can improve it. Yeah, we have really a good ways to improve it with this program. And yeah, he fell in love with this test and bug bounty challenges. So I will stay for a while on your program. That's really cool. So I came to the conclusions, to my conclusions. So what are the benefits of such a program? So on one, the biggest, or one benefit is we only have to pay per finding. It's not a commissioned pen testing where maybe 2 hackers try to exploit or bypass the WAF in a week. And at the end, maybe you get nothing, maybe an empty report or a standard scanner or something like that. And here you only pay per finding, but it's also cool for the hackers. They can send us multiple reports. It's really, you learn a lot. It's quite a fun to be on this platform. So we have a continuous testing here. So it's the whole year long. The WAF is attacked and got tested. We have a huge community. There are a lot of hackers. Currently, there are over 1,000 hackers, not active, but at least in the program. And it scales quite well. So first of all, regarding the hackers, but also we can add more challenges, add more technologies. Always when we develop a new defense feature, we can add a challenge and test it by the crowd. On the other side, there are also certain drawbacks. The biggest one is the limited scope. So as long as we do not put a vulnerability in there and do not attach, for example, this special database or this technology, you cannot test it. So that's of course a drawback. That means it doesn't replace all other forms of testing. So for example, black box testing. So it's only black box testing, so it doesn't replace white box testing. So somehow who takes a look at your code and looks for weaknesses in your code. Maybe in future we will also release parts of the code of the product to get more reports. How we think about that. And last but not least, the report handling is quite expensive. So we have to deal, for example, with duplicates. Usually it's or the first hacker with a unique idea gets the money, and the second one, it's a duplicate. He doesn't get the money, but this gives us pressure to fix all these vulnerabilities or these bypasses in a timely manner, because otherwise the hackers get frustrated, and that's not our goal. So we want to keep the hackers on the platform, so we really have the pressure to fix all these bypasses as fast as possible. Yeah, so my takeaways here is securing today's web. That's a big challenge. The web is by design insecure, or basically how we build software. Creates insecure systems at the end. But there are mechanisms, there are tools who effectively mitigate attacks. So a WAF is not only a marketing tool, so it really gives you benefit. Otherwise, we couldn't run such a bug bounty program. And it would really be cool if more security products would run such a program, because then you really can test it. It's not an analyst who says, yeah, this product is better than that, and you have on the web page, we do artificial intelligence and have 100% detection rate. When you cannot test it, then you can write everything on the paper. But with such a program, you can really test how good it is. So I would like, for example, to see that for a virus scanner. How good can it detect new viruses? Maybe it would be cool when I get money when I write a new virus which is not detected. And at the end, these capture the flag style programs, they are really cool for learning, for fun, for the hackers. But with this program, we could combine that to improve our security product. And I think that's really a cool thing. So you have seen the motivation for the hackers, and we really combine all the three top motivations. So they have fun, they learn things, and they get money. So yeah, this was my last slide. Or maybe here, when you want to get in touch with us, first of all, the most important thing, I think, when you want to participate in this program, in this hacker program, you can register an account on HackerOne. That's for free. Then you can go to the Airlock program, send us an email, and you can join our program. So everyone can join this program. And when you are interested in improving this bug bounty platform with more challenges, if you are interested in these kind of reports you have seen before, what hackers do, we also have open internship opportunities, especially next year, and you can write me a mail when you are interested in something like that. And yeah, we also have a lot of open positions at Airgon, junior software engineers in the project area, also in the product development, what we do. We have security engineers and internships, as I already said. Yeah, and last but not least, maybe you have already seen it, we have here on the booth in the D foyer, you can shape the future of our next rubber ducking. And yeah, there's a voting process, and when you have the nicest one, you can win a drone. And what we also have is here on where the red carpet is this flight simulator or virtual reality simulator where you can fly over Engadina. And yeah, that's more related to our field. Maybe you had heard the talk before from Daniel regarding spatial computing. It's more regarding our VR department we also have at Airgon. Okay, so that's all from my side. So do you have any question regarding our program?
Yes, first give it up for Reto for this very amazing talk. And we have a little gift for you.
Thank you very much.
Just adding to all these things that the Airgon Airlock booth has, they also have popcorn, fresh popcorn. That's why it smells like popcorn everywhere, so go enjoy that. So maybe I have a question, actually. So I was wondering about once someone submits a report, what is the process at the company then? Like, are you looking at them, comparing with other reports? How do you build it into the system?
That's a good question, because maybe you want to do an internship and then you're heavily involved in this process. So we have this platform, this HackerOne platform, where you can report a finding. And usually within 2 days, you get a response. Usually you get the money within 3 days or 4 days when it's really valid. But sometimes we have to analyze this report. We will discuss it internally. And yeah, you get the money quite fast. The fixing is a little bit more complicated. We cannot do that within an hour, so that maybe takes a few days. But then we redeploy the platform with the fix, and then you can retest your attack. And when you come again through the WAF, you get the second time the money. So that's possible. So yeah, that's basically the process, how we improve this platform, and indirectly with that, the product. And yeah, what we basically do with this report, we generalize the idea. So we do not block this attack string. That's useless. You cannot block an attack string like a pattern matching or something. You have to generalize the idea, what he really does, and then you have to implement a fix for this generalized idea. That's the only way the thing scales here. Otherwise, the hackers would ruin us because it's so easy to bypass a WAF with simple keyword search or something like that.
Thank you. Any other questions?
If a hacker finds a bug, how long does it take you to improve the WAF for all your customers?
Yeah, okay, the last part of your question was the interesting one. For all of our customers, we can improve the WAF quite well, but the question is, when does the customer at the end deploy the new WAF? And that's up to the customer, of course. So there are customers who have quite slow processes. There are other customers that are much faster. With a cloud service, you could do that maybe much faster. That's the benefit of the cloud. But we have still a lot of banking customers. For example, they do not route their online banking traffic through a public cloud provider. So they have an on-premise deployment. And yeah, there is not that fast, definitely. But at the end, I mean, you have to see a WAF cannot be perfect. That's a too difficult problem. And when you have a continuous improvement, it's not that important at which point you are, whether it's a one month before or 1 month after, because this product is never finished. So you have never 90.9999, and you can say now I do not do anything more, because there are always new vulnerabilities and ways to attack it. So, but yeah, that's a good question. Sometimes it really takes months for the customers to deploy that into production.
Okay, so I just want to ask if you could maybe talk about the different bounty platforms and why you went with HackerOne and not the competition.
Yeah, we evaluated the two biggest one. That's HackerOne and Bugcrowd, and we have no idea of these platforms before. So we simply where was the picture? We simply chose the biggest two, and HackerOne was the most flexible one. So we presented them our idea, and that's something completely new. They are usually only used to these productive systems where you can test Gmail or Apple.com or an IoT device or what else, and that's completely a capture the flag program here. And they usually host capture the flag program, but not such one where you have really a payout. So the other platforms, or especially Bugcrowd, I would say, were not so flexible. The price was more or less the same. That wasn't the issue. And HackerOne, is really cool, I think. And they found that's a cool idea. Let's do it. And it's also not so easy to discuss this program regarding this duplicate handling, for example, because they do not know that usually. Or for example, when you report here an SQL injection, that's not an SQL injection like you report it in for as again ETH set or so. That's an SQL injection only to bypass the WAF. The vulnerability is already there, and they are not used to that. And that was a little bit difficult with the other one. But we can switch to any of these platforms basically, because you have seen it's only a website, and they do the payout at the end, the registration. And yeah, there are a lot of hackers, of course, on this platform. That's good. But the base fee is quite high for the big platforms. So that's again the reason why I say it wouldn't make sense for us to make here a marketing bug bounty program, because the base fee is so high. We would pay out this money for nothing. So we really want to have hackers who find bypasses. Otherwise, we increase the bounties. So I will go up to my maximum budget I have at the end to get more findings, so that I can improve the product.
We have time for one more question.
Yep, I would like to ask, do you also have like a bounty program for like a system that is in deployment? So if someone finds a bug, like some way to bypass the Airlock in a deployment system, do you also give rewards to those people, or what do you do in that case?
Airlock in a deployment system?
Yeah, so for example, if someone were to find a vulnerability in one of your clients' website, it bypassed the Airlock, what do you do in that case, if that were to ever happen? Hopefully not.
Actually not. So we do not have a program where, so when you find a vulnerability in your online banking system, we do not pay out for this vulnerability. Because it really depends what the customer does with our product. He can deactivate everything, but as I said, I don't think that they have to do it, because we are really care about false positives. But at the end, we are not responsible for the configuration on the customer side. So they should run a bug bounty program. That would be the idea. But yeah, we have only this program at the moment.
Great. Thank you very much. Thank you for your questions and your wonderful talk. And yeah, give it up one more time.
Thank you.